This video is looking at environmental science and looking at energy, in particular nuclear energy, and how nuclear energy forms and where does this energy come from and why is it so effective at producing energy. This is the Earth Science Classroom. Nuclear energy is all about the power that is held or trapped within the atom, within the nucleus, within the atomic structure of materials, and the discovery and the scientific acquirement of knowledge and experiments, trial and error, and the ability to understand the atom from the nucleus, what's inside the nucleus, the proton, the neutron, the electrons, the orbital paths and fields, and the size of atoms and the isotopes and radiation in general, and the emittance of different particles like alpha and beta particles and gamma radiation, and the ability to understand how this energy is released from the atom in two different ways. There is nuclear fusion, where you are fusing and joining together atoms and elements in very high temperature, high pressure environments like the sun's core, or there is nuclear fission, where you are bombarding an atom with a certain particle like a neutron, and you are breaking or splitting apart the atom to release thus energy. So fusion is to release energy through combination, and fission is to release energy through the splitting of the atom. And this was all developed between 1845 up until the mid-1900s, and now we have nuclear energy. So in regards to nuclear fusion, which happens in the sun's core, various studies and research groups and labs are working on nuclear fusion on Earth at this point in time. However, this video is looking at the nuclear power energy generation, which is currently working in nuclear power plants around the world, which involves nuclear fission. So it is an exothermic reaction, means that it gives off heat in the reaction. And as I stated before, you are bombarding and hitting an atom that is naturally unstable, isotope, with a neutron at high speeds. This will cause the unstable atom or element to break apart and decay and release various particles and subparticles of radiation and energy like alpha decay and alpha particles, and emit gamma radiation, and also emit a ton of energy. Now the fuel or the element used, which is unstable isotope, is normally uranium-238 or 235. Normally uranium-235 is the more common fuel, or you can also use plutonium-239, which is more involved in the nuclear weapons side. But in terms of energy production in a power plant, it's mostly uranium-235 or occasionally uranium-238. Now, when we say uranium-235, we mean that uranium has 92 protons. It has the same amount of electrons, 92, as the protons, but it has more neutrons. It has 143 neutrons in its nucleus, so it is classified as unstable and isotope. Now, the mass is normally 238, but the mass is calculated by adding the protons with the neutrons. So you're looking at this very large atomic structure with a large amount of neutrons and just aching to break down and decay in its unstable form, which is why it's used in nuclear fission reactors in energy power plants. So nuclear energy is a somewhat efficient way to extract and use the vast amount of energy that's trapped in the atom. And a fission is where the neutrons go in to split the atom, in this case uranium atom, and release all the energy. Now this has been calculated to having 2 to 3 million times more energy than burning coal, burn the carbon in coal. So you can see why nuclear power plants have been a source of generating power and electricity compared to a conventional or old-fashioned coal power plant, where the amount of coal you'd have to burn to equal the amount of energy that is obtained through nuclear energy in the fission reaction in a nuclear power plant is unsustainable, to say the least. Thank you so much for watching the video. I hope you enjoyed it. If you like it, please subscribe and maybe hit the like button. If you like more on this content, please check out my channel, which has all these videos on earth science.